Hi. More calculus? That's what you wanted to do, right? Great, let's do it. This should be short and sweet. So in this one, it says find the values of f prime at the indicated values, and it's by using a graphing calculator. So I'm going to show you how to do that. And yes, it's still important that you know how to find derivatives, but there are certain instances where it can be quicker and just as good to find derivatives using your calculator. You won't find the function, but you can find a derivative at a specific point. So for instance, in this first one, and there's a couple ways to do this, if you have a calculator that looks like mine, TA84 Plus, this is how you're going to do it. I'm going to put this over here just so you can see, and I can see that A is equal to -2. I'm going to push math, and I'm going to go down until it says n deriv. And as long as your calculator is updated, and you could just push math 8, what's going to happen is this. And you're going to write D, and this is the derivative with respect to x. So I'm going to write that in here. Inside this parenthesis is your function. So 3e to the x power sine of x. And then I'm going to say I want this at x equals -2. If your calculator is not in radians, make sure that you go into mode and then you click on that and you push radians. But here you go. So my derivative, look at that, so easy, was f prime of -2 is -0.538. And I'm doing 3 places after the decimal just to get in that habit. And from this, if I want to know, is f of x increasing or decreasing? Well, I would know f of x is decreasing. And the reason is, it doesn't tell me to do this, but I think that it's good practice. F prime of -2 is less than 0. And then we do the next one. The next one, I could do the same way, and I could say math 8 and come up with the same thing, but I want to show you another way that works also. If you have an older calculator or one that hasn't been updated yet, which by the way, if you have this version but it's not updated, once we get back into school in the hybrid plan, I can update it for you. But this will always work too. You can go into y equals, and then I'm going to graph this. 3e to the x, and then I've got sine of x. And if I graph this, you're like, oh, okay, great, that's not such a great window. I just need to make sure A is equal to 1 is in there, so I'm going to make sure in my window, I'm going to set this to like a standard window. So -10 to 10, -10 to 10, and now graph it again. Just so I get x is equal to 1, then I'm definitely sure that it's in here. The next thing I want to do is second, sorry, it's kind of on my face. So second, and then I'm going to go up here to calc, so the one that says trace. Sorry, I guess I didn't push. There you go. Second calc, and go down to number 6, dy dx. You could just push 6, but I want to make sure that you know that I'm there. Push enter, and it looks like nothing happened. But in your graph, what you can do is just type in 1, and it says x equals 1 appears. If I push enter, the derivative right there is, and I can see that I have a positive slope, which is good. I know this actually works. My derivative is 11.268147. So I'm going to say f prime of 1, or I could say approximately, since I was rounding, 11 point, and then do 3 places after the decimal, 268. And then if I want to know, is the function increasing or decreasing? Right now I can look at it and I can see that the function is increasing. But if I didn't have graph, I could say f of x is increasing. And the reason is as f prime of 1 is greater than 0. Okay, then I have another one. So you can choose either way to do this. I just want to show you a couple things that could happen in your graph. So the natural log of cosine of x over x squared. Fun. Okay, let's go. I'm going to go back to my home screen because I like doing it this way. I'm going to push math, and I'm going to go down to 8, the one that says n deriv, the derivative with respect to x. Be careful when you're substituting this in because it's divided by x squared. I'm going to insert another parenthesis, and I'm going to say the natural log of cosine, where's cosine? There it is, of x. So it automatically opened a parenthesis. So I need to close the parenthesis for the cosine of x, close the parenthesis for the cosine. And now I need to close the parenthesis for natural log. Divided by, and just to get in the habit, x squared, put that in parentheses. Because it's all one term, you actually wouldn't have to, but if it was like x squared plus 3, you would have to. And then the very end, I want to say x at pi over 3. So I get f prime of pi over 3 is approximately negative 0.372. So what would this function be doing? It's decreasing. And I should say at x equals pi over 3. This one I should say at x equals 1. At x equals negative 2. So at pi over 3, and then my reason is as f prime of pi over 3 is less than 0. Okay, if I keep going, the next one that I'm going to do is this. Did you see me through that? Sorry, my dog is making weird noises, so I was trying to wake him up because he's sleeping. Okay, f prime of pi over 3 is less than 0. And the next one, I've got the same thing going on, so I'm going to show you a trick, or a quick trick on your calculator. If this one's at pi, if your calculator is updated, what you can do is just use the up arrow key, and then I push enter, and it automatically shows up down here again. So it just copies and pastes it for me. If it's not updated, you can push second enter, and it will get you back to the screen above that. You just have to be careful not to go too far. Okay, I'm going to delete this pi over 3 and just keep it as pi. I enter. Oh, and it says non-real answer. What do I do? So I'm going to go to this, and I already know that I put this in correctly before. So what I'm going to do now is I'm going to actually check out the graph and see what's happening. So if I substitute in a natural log, so where was the ln again? Why can't I find this right now? There it is. I don't know. It's been a long 2020 that I can't find that. Cosine of x. And again, this was all natural log. This is all in the numerator. If you want to put one parenthesis around the whole thing, you can. Divided by parenthesis x squared. If I graph this, and I want to know what is happening at pi. That's weird. But second, calculate the value at pi. I can see that this doesn't have a y value. So this just means that my function value, so I'm going to say f of pi does not exist. There's something going on there, and then I can't have a slope of a point that doesn't exist. So I'm going to say, therefore, f prime of pi does not exist. There are some cases where there is something called a vertical tangent, and in a vertical tangent, the point actually would exist. It's just going to be some sort of vertical slope at that point. But what's going to happen on your, like when your calculator does it, is your calculator is going to give you a huge number. It might say that your slope is like in the positive hundreds or thousands. And so what it's trying to do is connect the pixels to kind of together and do the best that it can to estimate the slope. So if you ever get some crazy high number, consider that there might be a vertical tangent going on. So just so you know, vertical tangents, then we would say the slope does not exist. Just like you can't have a rise of 5 and a run of 0. That's not possible to do. You can't do 5 divided by 0. Same thing with vertical tangents. So if this point would have existed, but this one still didn't, I would think a vertical tangent was happening. Okay, the next one. Oh, this is a crazy one, but I'm going to go back to this one. So math, and I'm going to just click 8 this time. So math 8, d dx, I'm going to say e to the tangent. Again, I shouldn't even show you. If I was in mode and this was in degrees right now, I'd be messing all sorts of things up. So make sure it's in radians. So this is derivative e the tangent. Which if you were substituting this in, oh wait, there it is, tangent of 0.34x, and I want this at x equals 0, f prime of 0 is approximately 0.340, and it's really important, even though that's the same thing as 0.34, write the 0 anyway, just so I know, because something's going on after the 0. This isn't an exact answer at 0.34. I'm going to say f of x is increasing as f prime of x, or f prime of 0 is greater than 0. And then last one, this one, the way that you write this one is a little bit crazy. So if I do, I'm going to write it over on the side first. Sine squared is the same thing as sine of ln of x, and then I'm squaring this whole thing. So what we're going to do here is I'm going to say, the way that I'm going to put this in my calculator is math 8, the derivative with respect to x, and then I'm going to put in 5, open a parenthesis, sine ln of x. So I have to close my x, my parenthesis from x, close it for the ln, close it for sine, and then I have to take the whole thing and put a little caret squared. I want to make sure I've got this right. Looks good to me. I'm not squaring the 5, I'm squaring all the other things. And this would be at x equals 1. And this one says negative 5.000 e to the negative 6. Well, if I was rounding this to 3 decimal places, this e to the negative 6 means scientific notation, so times 10 to the negative 6 power. Your calculator is doing the best it possibly can here to estimate 0. What's happening is f of x has a horizontal tangent at x equals 1. And the reason is, as f prime of 1 is approximately 0. And if you run it to write 0.000, because you know this might be a little bit off from this, or you're not really exactly sure, that's fine. But you could just say is 0. And the reason why is because if we actually did the calculator, or if we do this the long way, which I have before, I found this derivative and then I substitute in, we find out that this whole thing, this derivative, is equal to 0. And your calculator can only do so much, but you're smart and you can check it. Maybe not on this one yet, depending on how much experience you've had with the chain rule yet. Okay, we did it. Thanks so much for sticking with me. If you have any questions, please let me know. I appreciate you. Thanks for being here. Bye.